welcome to Cassandra.Lunch number 45. Today's today's topic is going to be Alpaca Cassandra and Twitter, and the talk is going to be given by Nikita Torasan, who's an engineering apprentice here at Anant. Our typical organizers for this event are Rahul. Rahul is unfortunately out of office today, but we are looking for other co-organizers who can help find speakers and sponsors. So essentially just help get the word out, bring a friend. And then currently we're in a virtual environment, but generally when we're in person, we usually get pizza and soda. So getting sponsors to help with that helps everyone have a better time. If you are interested in being a co-organizer, you can reach out to Rahul at rahul@anant.us. We are a part of Data Community DC. Data Community DC is a diverse community where we build no matter your race, creed, gender. It's about being an inclusive community that talks about data. Data Community DC is made up of a bunch of different groups, including Data Viz, Full Stack Data Science DC, Statistical Seminars, Data Wranglers DC, which is also where we host our Data Engineers lunches every Monday at noon Eastern. So if you're interested in that, you can find that on the meetup pages. You can also visit datacommunitydc.org to find out what other events are being hosted in the Data Community DC community. So what do we cover here at Cassandra.Lunch? We essentially cover the Cassandra protocol and anything that is compliant with the protocol or uses the protocol. So that includes open source Apache Cassandra, DataStax Enterprise, DataStax Astra, other tools like Skilla, Yugabyte, Keyspaces, Amazon Keyspaces, and Azure Cosmos DB. And this is generally a portion where we ask people, generally, if we're in person, take a couple minutes, go talk to someone you haven't. But right now, because we're virtual, we have people who are new and would like to potentially say hi, what they do with Cassandra, or potentially what they want to learn or could potentially speak about. Looking through the participants list, and it doesn't look like anyone's new, so we'll just go ahead and move on. So group roles, because it's a community, if you have a question, you can ask it. Depending on the speaker, they may prefer you to ask it in the chat and they might find a good stopping point to get to it. But generally, the rule is just to be polite and courteous. And most of all, because we are a community, feel free to share what you know with us, because the more everyone knows, or the more you know, the more everyone knows. So here at Anant, we work on designing, building, and managing global data and analytics platforms. DataStax is a partner and a sponsor of this event, or this meetup, and GW is also a sponsor because they help us give us venue space when we're doing in-person events. We also have some organizational and institutional sponsors that help us put on these events, again, like I mentioned, helping us get pizza and soda when we're in person. This is a section where if you have any jobs or if you are looking for a job, you can go ahead and speak up, or you can drop it in the chat if you have any links. If you have any meetups, hackathons, classes, events that you want to plug, you can go ahead and do that as well. And you can throw that in the chat or speak up if you have any events coming up. Okay, doesn't look like there's anything in the chat. So we typically have ongoing events. So DataStax has weekly workshops. This event every Wednesday at noon Eastern, Apache Cassandra lunch. And then on Mondays, we also have our data engineers lunch at noon Eastern as well. A couple upcoming topics that we are planning on talking about and are in the backlog are Airflow and Cassandra. Rahul is already putting on the Kubernetes and Cassandra talk. He wrapped up part 2 last week. So if you're interested in how to do Cassandra on Kubernetes, you can go back to our YouTube channel, youtube.com/AnantCorp, and then you can either find it on the main videos page or under the Cassandra.Lunch playlist. And we also have Jenkins and Cassandra on the backlog. All right. And again, if you're looking for previous Cassandra lunches, we started recording this event around Cassandra Lunch number 10. So the first 9 we don't have, but from 10 up until 44, they are available on our YouTube channel, youtube.com/AnantCorp. And then we also, as a company, Anant, put together Cassandra.Link, which is a hand curated site with all the best Cassandra resources. Um, so if you're looking for a certain topic, you can just go to Cassandra.Link and search for it. And at this time, we will wrap it up and we will pass it over to our speaker, Nikita.
All right. Let's see. Can everyone see my screen? Are we good?
Yep.
All right. Does this show?
Yep.
All right, cool. As Arpan said, I'm Nikita. I'm a software engineering apprentice at Anant for a few months now. And today I'm going to be talking about using something called Alpaca Cassandra to save data to a local Cassandra database. In this particular demo application, which I'll have a GitHub link to at some point in the chat. In this particular demo, we're pulling data from Twitter. Since Alpaca Cassandra is in Scala, I'm using a Twitter client written in Scala called Twitter 4S. It's pretty well known, I believe most well known Twitter client for Scala. But the data isn't specific to Twitter. Twitter and Alpaca Cassandra don't have like a special relationship. So first I'm going to talk about, or just a little bit about Akka and Akka streams in general. You could have entire like multiple hour long talks, and there exist a bunch on like YouTube and stuff for Akka and Akka streams concepts. But probably the best way to learn about this stuff, if you're interested, is to read the documents that a company called Lightbend has on Akka and Akka streams. So what is Akka? Akka is a free open source toolkit and runtime for making concurrent and distributed applications on JVM. Akka's approach to concurrency is based on something called the actor model, where basically everything is an actor. They can receive messages and send messages asynchronously, and actors can also create other actors to then go and do stuff. And they have like a parent-child actor relationship. Akka is written in Scala, but can be used as either Java or Scala, as both Java and Scala compile to JVM code. So then Akka Streams is a library in Akka, which is used to deal with processing a sequence of elements using a complicated term called bounded buffer space. A few key terms that I'm going to mention from Akka Streams, which are important to sort of like this technology and this like demo project, are a stream is an active process that involves moving and transforming data. Then I'm going to mention 3 components of Akka Streams, which are important. One is a source, which is an operator with one output, which, as the name may imply, emits data elements as they are requested from it. So then we have a sink, which is like the opposite of a source. It's an operator with one input, which requests and accepts data coming into it. And finally, we have a flow, which is an operator with one input and one output element. It connects its upstream and downstream by transforming data elements that flow through it. So you might have a flow to like multiply everything that comes into it by 2 if it's expecting like integers. Or in our case, I'll talk about Cassandra Flow in a minute. And then finally, we have a runnable graph, which is a flow that has one end attached to a source and one end to a sink and is ready to be run. These can also be like larger things. So you can have like one source and then like 20 flows and then one sink. but you need a source, a sink, and a flow. Or maybe you can probably just attach a source to a sink, but it wouldn't do much. And then the AccaStreams library automatically deals with back pressure. So any component that receives elements from a previous component will only receive them when it's ready to do so. And otherwise, they're kind of stored in like a space. They're not, messages aren't like deleted just because they're not ready to be accepted, which is cool about Akka and AccaStreams. All right, and then Alpaca is an open source initiative to implement stream-aware and reactive integration pipelines for Java and Scala. It's built on top of AccaStreams and is reactive streams compliant. So if you work with other pieces of software or things that are also reactive streams compliant, then they will probably work together. So Alpaca provides many AccaStreams integration implementations for different databases, and also provides many classes and functions for dealing with a few common data transformations. A few of the databases that Alpaca supports are InfluxDB, MongoDB, Elasticsearch, Apache Cassandra, as we'll use in this demo project, and there are quite a few more. And then some data transformation sort of like modules that Alpaca has are things for JSON, CSV, XML, and some other ones. All right, and the portion of Alpaca dealing with Apache Cassandra is called Alpaca Cassandra. So the demo project uses Alpaca Cassandra, which provides an AccaStreams API on top of a SQL session that you might know from the DataStax Java driver for Apache Cassandra. In particular, Alpaca Cassandra provides Cassandra source and Cassandra Flow, which are AccaStream sources and flows respectively. So a Cassandra source basically gives you an AccaStream source from SQL queries and from DataStax SQL statements. So you'll usually use a Cassandra source to pull stuff from a Cassandra database. And then Cassandra flows, Cassandra Flow obtains an AccaStreams flow to run SQL statements that change data. So if you have some kind of data, you throw it from some kind of source into your Cassandra Flow, and then set up the statement there to save that data to either local Cassandra database or remote or however you have it set up. And it'll save to Cassandra through that flow. And then you can send it to a sink or do whatever you want with it. Previous versions of Alpaca Cassandra, I believe before they switched to 2.0 in the past like year or something, or maybe a couple years, used to have an implementation for Cassandra Sync, but the developers pretty much realized that a sink is equivalent to having a flow which goes to a sink.ignore, which is a sink that just takes in elements and does nothing with them, and that's it. And so Cassandra Sync was removed in later versions of Alpaca Cassandra. So this is just a little diagram of the AccaStreams source flow and sync that are used in the demo application. We use a source called an AccaStreams source.queue, which basically lets us at any point push stuff into the source, like new data or new tweets that we want to save to Cassandra using the .offer method. Yeah, so as we get tweets, as you'll see in a bit from our Twitter streaming client, and we'll take them, we'll offer them to the source.queue, and then they'll run through this runnable graph and it'll do stuff. For the flow, we use a Cassandra flow from Alpaca Cassandra. As data comes into the flow, and assuming it's the correct type of data, then it'll be written to our local Cassandra database. And then afterwards, the data is sent to a sink.ignore, which is one of the default sinks in AccaStreams. And as the name may imply, when things go to sink.ignore, nothing happens with them. They just gets ignored, that's it. It's over. So I guess last big piece to talk about here is Twitter 4S, which is a Scala Twitter client. It's not official. It's a Twitter client written in Scala, which uses Twitter API version 1.1, I believe, and is implemented using Akka HTTP. If you wanted to, you could manually write your own sort of like Twitter client with Akka HTTP, but since it already exists and I was writing a Scala application, then this was convenient to use. Using Twitter for us allows for an easy way to pull things from Twitter in a Scala application without having to deal with Twitter API directly, right? But you could use Akka HTTP in an Akka application to make API calls yourself. Usage of the client requires a Twitter developer account and application for the necessary API keys. Yeah, you go on the Twitter developer website, you need to have a Twitter account, then you like apply for a Twitter developer account, and then you finally have to apply for an application. This may take, 12 hours to a day to get for them to get back to you. I don't remember, but it shouldn't be a problem to get the keys you need if you want to try this out yourself. And so I will talk about what the demo project uses during the demo. And finally, the Scala application is built with something called SBT. SBT is an interactive build tool for Scala and Java projects. A large majority of Scala projects are built using SBT, and demo project is no exception. More information can be found at that link. All right. So, so the demo project. The demo project includes a detailed README. I will link it in the chat in case anyone wants to look at it right now. Or Arpan, do you have a link for it? Can you link it for me?
Yeah, I can send.
Okay, thanks. But basically, a rundown of what we're about to go through is, well, first we pull the repository. Then we are going to run Cassandra locally in a container using Docker. Going to set up a very basic key space and table just for this demo using interactive CQL SH console. It is, I believe, possible to make all of this also work with DataStax Astra, which is Cassandra as a service. This project doesn't use that right now, but it shouldn't be too hard to configure this and make it work. So after we run local Cassandra, we are going to make an application.conf file using the example file in the repository. And the only thing you have to change in the file, if you're following along, is you have to fill it in with the proper Twitter API keys that you get from your own account and from your own application. We're going to run the project with SBT. And then as tweets come in for a particular hashtag, which is just how I've decided to filter what tweets we end up trying to save to Cassandra. But that's also easily changeable. And as tweets come in that are eligible, I guess, under these criteria to be saved to Cassandra, we can then take a look at the local Cassandra database to make sure that, in fact, we are actually saving stuff to Cassandra. All right. Cool. Second. Okay. So yeah, Arpan linked the GitHub repo. All right. So one important thing to note here is that you do need JDK8. If I open up a terminal, type java-version, say I have OpenJDK 1.8. The reason you need JDK8 for this project is because Twitter 4S, so the Twitter client we're using, does not work with more recent JDK versions. Right. So the first thing we're going to do is we're going to use this command here to run a run Cassandra using Docker or in a Docker container locally. We're going to bind to port 9042. We're going to call the container my Cassandra. You can change the name if you'd like to. And then if you haven't used the Cassandra Docker image before, the first time you try to run this command, it will have to pull the Cassandra image, which might take a few minutes. But in my case, if I type in Docker images, it shows me the images I have, and I do have the latest Cassandra image. So we're going to do this. Then we're going to use the command docker ps-a to list all of our containers that are running. We see we have our my Cassandra container running for 3 seconds now. So before launching CQLSH on this container, we're going to give it a minute to boot up. This is probably enough time, but it can take longer depending on your specific setup. So now we're going to open up CQLSH. And here we're going to create this very, very basic key space that we're calling test key space with just replication simple strategy, replication factor 1. We're also going to make a table for this key space called a test table, where the table is going to have 2 columns. It's going to have a big integer column ID called ID, which is also going to be our primary key. With our use case being trying to store tweets, every tweet actually has its own unique ID. So it's perfectly fine here to have the ID of the tweet as the primary key, as we won't have any uniqueness issues. So we're going to make table. All right, there we go. I'm going to insert this basic, just sort of a test entry. This part's not necessary. And then we can exit CQLSH. All right. Okay. So next, well, I should have first cloned the repository. So I can grab the URL, open up terminal, git clone. All right. Then I'm going to open up the repository in VS Code, demo directory. All right. So when you go to source main and then the resources folder, there's going to be this file right here called application.conf.example. The only thing you have to change here is this section at the bottom, which into which you have to put in your Twitter consumer and access keys. I already have this file filled out, so I'm just going to copy it into this directory. You don't have to delete the example one, but there should only be one file in the resources folder that's called, application conf. So I'm going to grab my already pre-filled in application.conf, going to copy it over to the repository I just cloned, resources, paste. All right. So we've set up Twitter stuff. And now we're going to look at the code for just a second. Main code for this project is under source main, Scala com, Alp Twitter, and then this one file here. So a few things to note. I have a case class defined here for sort of the format of tweet that we're saving to Cassandra. As I mentioned before, when we were making our table in the test key space, we had 2 columns, which was an ID, which was a big int, which corresponds to a long in Scala. And then we had a text field, which is just text in CQL. But in Scala, that's a string. If you look at the Twitter 4S documentation and you look at what a tweet looks like, you see that there are a billion different fields. So as it turns out, every tweet that is saved on Twitter has a lot of information in it, including like location and how many like favorites it has, how many retweets it has. But in this particular example, we're only going to be saving the text of the tweet and the ID of the tweet, which ID is just a long. So additionally, on this line right here, where we define a variable called tracked words, which is a sequence of strings. This is where you'd input what hashtags you want to look at. So we could do like Apple, or in this particular case, I'm just going to be using a hashtag that I know isn't too used, but also gets enough tweets every few seconds, such that we should be able to get some tweets that aren't retweets of a tweet, so that we can actually save something to Cassandra and see the software working in real time. So I'm going to, one second. So I'm going to open CQLSH again on my Docker container, just to show that we have nothing in our test table, or rather we have our one entry that we put in before. And we're going to open up terminal. Gonna make sure we're in the right directory. Yep. And now we're going to run the application. This will take a second. If it's also the first time it's being run, it might have to download some stuff, or building might take a minute. So we'll see. All right. Might get some warnings, but that's fine.
Hey Nikita.
Hmm?
What packages do you need for like your SVT properties?
One second. What packages would that be listed under here, right?
Mhm.
We just use the Twitter client, so that needs to be added to build.spt. We use some Akka stuff like Akka streams, a bunch of stuff that Akka needs, and that should be it.
Cool.
Oh, and then also one thing for Alpaca Cassandra in particular. So basically, Alpaca Cassandra, Twitter client, and basic stuff that Akka needs.
Can I ask a trivia question?
Yeah, sure.
Why Visual Studio?
It's free. It's free and it works. Is something wrong with Visual Studio, or?
No, just trivia question.
All right. So we're gonna run the application again. So one of the things that this, so basically every time that somebody presses the retweet button on a tweet on Twitter, it actually gives that retweet of that tweet its own like Twitter ID. I didn't want to save tweets that were retweets into this because you're just saving a bunch of, I guess, duplicate tweets kind of. You could though. But in this particular case, as our tweets come in, we're saying if we're matching on tweet.retweeted status. And then if it's a retweet, then we just print this is a retweet of a previous tweet, will not save. So we can see here for the hashtag I chose, we're getting a bunch of retweets, probably like giveaways or something along those lines. And then once we find a tweet that is not a retweet, then we'll save it to Cassandra. Hopefully this will check CQLSH. See, we have nothing. This may take a second. This is pulling real-time data from Twitter though. May have to switch the hashtag we're using in a second. Use something more popular. And again, like something like hashtag Apple is probably really, really popular. Additionally, we create this streaming client. Val streaming client equals Twitter streaming client. And then we apply this filter statuses method on it, where we give it the hashtags that we're trying to filter for. If you look at the Twitter 4S documentation for this, there are a few other things you can filter the public Twitter stream based on. Like you may be looking at tweets by only particular people, or something along those lines. But here we're just looking for particular hashtags. Also, sometimes you may get disconnected from this Twitter client. Inside of this filter statuses method, we're only looking for the case of receiving a tweet. But if we look at the documentation, it can also sometimes give us a notification that we're like hitting a rate limit if we're looking at a particularly popular hashtag, and based on whether Twitter wants you to pull enough tweets or not, or if, yeah, it may give you some issues. It seems like I may have been disconnected as we're not getting any more of these messages, which is unfortunate. We'll try rerunning it, see what happens. Hopefully we can get a couple tweets here that are unique. No, it's okay. It's okay. We'll find something soon. All right, so we can see now we're getting some activity on this particular hashtag, but they're all retweets, which is a little bit unfortunate. Never had this much trouble getting one tweet in. I'll give it another 30 seconds and then try something else if it's not working out. Come on. Yeah. This is real time though. I guess there's a bit of a risk with me not having a burner Twitter account ready to tweet something out on my own custom hashtag, which I probably should have done. In this particular case, I guess a bit of trivia. I'm using the tweet hashtag CSGO, which comes from a popular game and also esport called Counter-Strike. And there are a lot of like Twitter campaigns for this hashtag that basically do like all sorts of giveaways. And, like to enter, you must retweet. So this is probably what all of this is. We're not getting very lucky, are we? Okay, I'm gonna let this run for a second. Keep it at the bottom. But here, if we go to Twitter and we go to the Explore section, we can type in a hashtag, for example, hashtag CSGO that I've been trying to look at, and go to latest. And we can see that the last tweet was 3 minutes ago. Then there was a unique tweet 7 minutes ago, another one 7 minutes ago, 9 minutes ago, 10 minutes ago. Very unfortunate we didn't catch this one from 3 minutes ago. I can try something else. Hashtag 5G. Oh, this one's really, really active. Okay. Okay, let's try 5G instead. Try hashtag 5G. Should hopefully give us some results. Twitter's being a little slow. Okay, it's fine. Takes a minute to build. If we refresh this, we should be able to see. All right. There we go. Okay. So we almost immediately found a non-retweeted tweet. Can let this keep running. Don't have to though. So now we can check our CQLSH. Still have this terminal open. We can see that we did manage to grab a tweet. If we take the idea of this tweet that we grabbed, we copy it over. We go to, for example, the Twitter profile of CEO of Twitter, Jack. We type /status, and then we put in that tweet ID. We could have used any user. Twitter will figure out who the tweet is from. We can see that this tweet came in at 12:39, April 14th. So we got it live. And there we just found a bunch more. So if we select star, you can see we're getting a bunch of real-time tweets from Twitter. And they're being saved into our database, which is pretty cool. Yeah, unfortunate that I chose a very dead hashtag at first. But yeah. So I've stopped the project. Oh, also, some of these tweets you can see they're like kind of cut out, like this one, for example. It says like is really driving the ... and there's a URL. If we open up this tweet through Twitter, I'm going to paste the status in, take a look. We see that the actual tweet is a little bit longer than what we saved into here. And that's because if you look at the tweet object from Twitter 4S, by default, the text in the tweet is actually a truncated version of the text. So originally tweets had 140 characters maximum. And then at some point it was changed. So now tweets can have up to 280, I believe. But Twitter API will give you, at least in the default text field, it'll give you the non-extended version of the tweet. But then somewhere under here, like if we looked at the extended tweet field, then we could find the full text of the tweet and save that. But that's not an issue. This isn't, I guess this application isn't super useful. It's just demonstrating that we can pull real-time data from Twitter and, well, yeah, save it locally. I think that's about all there is to this demo project. Oh, additionally, this demo project does actually use one Cassandra source, right? Or which is our, well, which is basically this line right here. Thanks, Josh. So all we're doing is we're selecting release version from system.local to show us what version of Cassandra we have every time we boot up the application. So if I run the project again, that's what, or I'll just scroll up in the output a little bit. See right here, I have 3.11.10. Also, with the way that futures work in Akka, even though this, like, we sort of start this before we start getting any like tweets or start trying to save anything, it is possible that this version number could still print after one of these things. That's just how these asynchronous things work sometimes. But most of the time, the version number will print beforehand, and there's no actual necessary reason for this to print. This was just me sort of seeing if I could read from my Cassandra database. And then there's also a commented out a line here that makes a Cassandra source to pull a sample entry from the table. And then when we're done, we want to, we see that we still have our Docker container open. It's been up for 20 minutes. We do Docker stop my Cassandra, and our container is gone. Additionally, when we started running that version of, or when we started running Cassandra locally, we used this flag right here called RM in this Docker run command. So what this will do is that as soon as the Docker container is stopped, it'll also actually remove it. So any data that we saved into this database is now gone. If you run it without the RM flag, then it won't remove the container. It'll only stop it when I use the Docker stop command. And so then you can, at a later point in time, resume that container, and you'll still have the data that you saved into there. But if you actually want to more permanently save data, then you have to Akka versus Kafka streams, use cases for each. Unless someone else is able to answer, I don't have experience with Kafka streams. Or in fact, before this project with Akka streams either. And I guess that'll be it for the demo.
Yep. Great job, Nikita. Jay, for your question, I don't have much experience as well with Kafka streams. And this is kind of my first look at Akka streams as well. Pramod and Javid or Sunny, do you guys potentially would have some use cases for whether you would choose Kafka streams or Akka streams?
This is Javid. When we used to work for Capital One, they mostly using the Kafka stream, not the Akka, because I don't know they might use or not. But the Kafka was being used a lot in Capital One for streaming the data because it's a credit card basis and they just want to get the transactions and the feedbacks. One of the team was there in. I don't know the exact name of the team, but they used to get the feedbacks directly from any of the purchases or any customer was giving any feedback to a particular transaction, what happens. That was they used to do the Kafka stream to consume the data from the live stream, I guess.
Cool. Yeah. Nikita, you may know a little bit more, but does Akka have some sort of partitioning system, like a partition queue? Or like you were mentioning that like it handles back pressure, right? And so
yeah,
it kind of holds off. So like in Kafka, we have partitioned queues where we can kind of set that. And then you kind of mentioned it was just like held in space. Like, do you know what that space structure could be?
I don't fully understand it, so I'm not going to pretend to have a good answer for that. Sorry.
See if Akka has a partition queue. So Akka does have a partitioner, but it seems like it's to.
Sorry to interrupt. In Kafka, I just there are 10 for one user. There will be 10 partitions, I guess. I might be wrong, or I just giving an hint.
If I missed it, sorry, Nikita. Did I hear you say something about like graph? Does stuff with graph? That part.
Say that again.
At the outset, I thought I heard something mentioned about the demo doing stuff with maybe data stacks as graph?
No.
Okay, sorry.
I don't believe so. Yeah. All right.
So I think that will wrap it up for the meetup. Thank you for everyone for coming out. Thank you for Nikita for giving the presentation today. Next week, I believe I'm giving a presentation on running Apache Spark jobs in Cassandra. And we'll probably, just as a preview, also potentially look at like SBT or depending on what you're using with Spark, you can build using like POM XMLs, or you can use SBT to build your packages or to build your jar that you then pass to your Spark job. Still a little undecided. Probably just use SBT because it's simple and I've used it before. But yeah, that's a preview for next week. And again, thank you for everyone coming out. If you want to catch up on Cassandra.Lunch, the past videos can be found on our YouTube channel, youtube.com/AnantCorp, and subscribe to keep up to date with the most recent live recordings for Cassandra.Lunch and also Data Engineers Lunch. Thank you.
Thanks, guys.
Yep.
Thank you all.
Thank you.
Thank you all.